Hello everyone, it's Benny, and in this video, we're going to finally start doing some level design. In this video, we're going to build a simple test level, or at least start to, where we'll have some rooms, we'll have some enemies we have to run around, we'll have doors we can open, we'll have locked doors we have to solve puzzles to open, or find items to open, and maybe we'll have a boss at the end, I don't know. We'll level up, do all the basic mechanics in this giant test level. And that'll be the goal. So yeah, that's what we're going to be doing in this video. However, before we start that, there's just two very small things I'm going to do. And they're not really big things, just little things to make the code a bit better. And first up is in the stat scale. We have this method right here, which generates stat scales. And it works, it's perfectly fine. Here's the thing though. As you can see right here, what we did is we set it up so if the random number generator doesn't generate a valid stat scale, it says just screw it, trash it all, try again. And that was perfectly fine in the Java method because there were very few fail cases, so it was unlikely that this would fail and take a long time. So that was perfectly okay. Here's the thing though. Now we've taken our own random number generator. See, RPG random, rand. We're using our own random number generation system, and that has a lot more fail cases. It can generate numbers above 1, so that would fail. It can generate numbers that are negative, so those are all fail. And, it's just, at this point, why bother? It was nice because it was easy, but I'd rather have a method that couldn't fail at this point, so we're just going to scrap this. We're not going to have any fail cases, and we're going to generate it like that. So first step to this is I'm going to take the absolute value of whatever random number we're given. Because this way, I don't want negative stat scales. It's not my intention. So yeah. Now next up, for sum, instead of summing the squares, I'm just going to sum the values. Why? Because in this first iteration, the way I'm going to do it now is I'm going to generate the scales as the squares, and then in this second normalization process, that's when I'm going to take the square root of them. So this way, it's going to make it a little bit easier to make sure everything sums to 1. That also means I'm not going to need to take the square root of the sum, so that can go ahead and go away. So now, scales divided by sum. This should normalize everything to be between 0 and 1, which is good. That's what is wanted. However, I do have a minimum to my stat scales. Wait, that's max, sorry. 0.125. So this is where things are going to be a little tricky. First off, I'm going to scale this entire region. I'm going to scale the scales. So, scales times equals. And what I'm going to do is I'm going to do 1.0 minus min stat scale. So, essentially, there. Essentially what this is going to do is it's going to decrease the region so it's only between 0 and the biggest it can be minus the stat scale. So this way all you have to do is add on the minimum stat scale to every single one, and everything's perfectly within that region. The only issue with this is right now everything is squared. So I have to do some interesting math to make this work. First off, I'm going to multiply it by, I'm going to of course square this. And that all makes some fair sense because, I'm dealing with the squares, so subtract the squares instead of the non-square. This is where things get a little bit weird though. I'm going to multiply by the number of stats as well. And actually, this will make a lot more sense once I just get the next line of code written. So I'll hold off on telling you why that's there until I get the next line of code written. So, scale sub I. Now I'm going to add back in the min stat scale squared. And that way, this keeps everything within that region between min stat scale and 1. And the reason I have this multiply by num stats here is because, well, let's say I didn't. The thing is, if every single stat is less than the minimum stat scale, it makes sense if you think of it like this, but here's the thing. I'm multiplying, I'm scaling all the scales by this value. So if I added all this back in, this would not end up being, it would not go back to 1 because, you know, it's scaling everything by this value. It's not directly subtracting minimum stat scales. So that's why I'm multiplying by the num stats, because that'll account for the normalization. It's normalized over 8 values, so I'm going to multiply by that many values. And it makes everything work out. And just to prove it, I'll go ahead and create a second sum. So double sum 2, just to prove it to you. So, yeah. Sum 2 plus equals scale sub I. And go ahead and print it out. Sum 2. If this works, these should both be 1. And 0.999998, that's floating point precision error. That's still technically 1 by all intents and purposes, and 1. So yes, this does indeed work out, and to show you what happens if that doesn't happen, if I don't have that there, yeah, they both add up to 10375. So yeah, that's the reason that I'm also scaling it by the number scales. You have to account for this normalization over 8 values. And yeah. Whoops. So after all that's done, really there's only one thing left to do. And that is take all the scales and square root them, because everything's been done with the squares so far. So just go ahead and square root all the scales. And there, that should be everything. And I can sort of compact that, I guess. So I generate the scales and then I normalize them. Pretty straightforward. And again, to prove this is working, I'm going to go ahead and just print out the stat scales. So toString. And go ahead and close that out. You see, these are the stat scales we generated. Notice nothing below the lowest possible value. And if I did the sum of all the squares, well, I already showed that off by doing that experiment. But yeah, if you take the square of all these and sum them, they do indeed add to 1. Meets all our conditions, and it's pretty great. So yeah, much better than our previous method. And yeah, that's all I really wanted to do there. So yeah, just go ahead and get rid of this line and move on to the next one, which is going to be much, much easier. Okay, and the other thing is, you people are awesome, because if you remember in the last video, I was having some issues getting these constructors working, and people just posted in the comments just amazing solutions to this, so thank you. You people really are awesome. It's amazing when you do things like this. I can't tell you how much this makes me happy, but yeah. Here's all I had to do to solve this ridiculous constructor problem, thanks to you people. This, and then pass in the seed. I'm not sure why I didn't think of this, but hey. And someone was also kind enough to suggest a really good seeding mechanism. So system.out. Wait, what? No. System.current. Nope. Come on, IntelliSense. Current time millis. So this way, it'll just seed based on current system time, which is fairly indeterminable. So, oh. And I can just cast it to an int. And since you really won't know when this method's being called, it's essentially random. So yeah, there you go. This completely solves that ridiculous constructor problem I was having. So yeah, thank you very much, everyone. It's fantastic. But yeah, with all that done, the next thing we need to do is just start making this test level. You ready? Alright, so our first step in building our test level is just making a plan. What do we want our test level to do? What do we want it to look like? How do you want it to work? And I know this seems somewhat trivial, but it's actually really important because we're about to do a whole bunch of coding, and it's going to take a while. It's going to not be a trivial task. So even though this may seem simple and trivial, it's very important to plan things out, because this way I know everything that needs to be done beforehand. I don't get halfway through the process and be like, oh no, I actually didn't need to do this thing I just spent 10 hours doing. And yeah. Or maybe I have built this test level and all of a sudden, oh no, it needs to be completely different. I need to redo the whole thing and lose everything. It's just always much better to plan out ahead. It's just, yeah. So, I'm just going to go ahead and start planning out the test level. So first off, I want to start off with a basic room. That's the first thing I want to be able to create in the test level. A room with our... Actually, I'm going to go ahead and select the green color. So, I'm going to go ahead and select green. We're going to have our fabulous green player in there, which for some reason is not loading. There we go. It didn't... Why is it lagging like that? Whatever. Apparently it doesn't like me drawing, but yeah, there's our fabulous green player. And yeah, so it's going to be in this simple room, fairly simple anyways, and I need a color for doors, so I'll choose brown. Oops. Okay, that works. So then I'll have a little door here. So we'll have a door. We should be able to open it, of course, and go through. And of course all these walls should be blocking us, so we shouldn't be able to go for the walls or get stuck in them or whatever. And yeah, so next up, what I want is, whoops. For some reason it's always lags when I hit it, but whatever. Next up I want hallway. And which color should I have monsters be? How about red? Yeah, I'll have a monster in here if it draws. Come on. I believe in you. I believe in you, Paint.net. You can do this. It really does not like me doing this when I'm recording. There we go. Much better. Alright. And come on. What? Well, this isn't exactly working out, but okay, whatever. I'm not going to fill it in. Apparently Paint.net doesn't want me to, so I'm not going to push it. Although, actually, I should probably get rid of this, shouldn't I? Yeah. Because this is going to lead into another room. Whoops. So, there you go. And in this room, I want to have a key. So I'm going to have to pick up items be this. And come on, Paint.net. You can do this. Okay, there you go. There's our key. No idea why it's doing this, but hey. Whatever. So, I'm going to go back to black. And what that's going to do is that's going to open a certain locked door, actually. So, shouldn't have actually gone back to black. It's going to open this door. There you go. And in this door, I'm going to have another sort of squarish room. And that's where I'll fight the big bad boss. So, yeah, it's not doing it anymore, thankfully. So this is going to be our test boss monster, which should hopefully give us enough experience to level up. Not sure why I'm not using the fill tool, but hey, whatever. It works. So yeah, this is sort of the layout of the test level. Now I'm going to try filling this in now, see if it lets me. Hang on. Come on. There we go. Sorry, that was bothering me. But yeah, there's a locked door. It requires a blue key or whatever to get through. And we'll fight the monster there. So, awesome. There we go. That's going to be our test level. And, yeah, so this gives you a little bit of an idea of what we're actually supposed to do in there. And, oh yeah, there should be some reward for you to be defeating the boss. So maybe it drops some item. See? This is why I plan things out. I almost completely forgot about that. So, yeah. Maybe it... I don't know. I'll try drawing it inside of it. So maybe it has this little purple thingy in its belly. Maybe there's some damsel in distress at 8. I don't know. But we have a boss monster. And this is going to be our test level. So yeah, this is what we're going to start making right now. Okay, so the first part of the task I'm going to do is I'm going to implement walls. Because right now we don't have a way of actually adding walls to block the player from moving. So let's go ahead and add that. First off, I'm going to do it by our classic ID system. So I'm going to have a wall ID. It's going to be 4 for now. I can change it anytime I want. And yeah, it's... there we go. Yeah. And I'm going to actually change movement to be part of the update method. So what I'm going to do is every time I update, rather than moving in the move method, I'm going to defer it into the update method, because that way I can tell if there's going to be a wall in the way. So I'm going to create some more data. Private int move amount x and private int move amount y. So I'm going to initialize move. Actually, I should put the above tactile, shouldn't I? Yeah, I'm going. Actually, whatever. It doesn't matter. I'm going to initialize a move amount x to 0 and move amount y to 0. So yeah. And where's the method I'm looking for? Here we go. So rather than just directly changing our x and y here, I'm going to say, whoops. There we go. Move amount x plus equals that. Actually, I should probably just not even bother with this commenting thing. Just directly change it. What am I doing? Move amount x and move amount y. So there we go. We have wave moving. And where's our other code? Here we go. Now in our update method, we're already checking everything that's essentially in a giant collision radius. So yeah, we're checking everything that's hitting us. However, I'm actually going to change this code. I'm going to create 2 new variables to do this. So first off, I'm going to create... what should I create? Yeah, whatever. Why not? I'm going to create... yeah, I'm just going to create 2 new variables. I was thinking about something else, don't worry about it. I'm going to create a variable called newx, which equals x plus move amount x. And I'm going to create an int new y, which equals y plus move amount y. And... yeah. And this is... okay, I guess I'll have to cast to floats. That's fine. I can do that. Oh, right, because movement is itself is a float, okay. So, whoops. And I should cast these to floats anyways, because, you know, it's just nice to explicitly cast variables. So yeah, I now have the new x and the new y, and I'm going to change these. So I'm going to calculate based on the position I'm going to move to, rather than the position I'm currently at. So yeah, this is going to be my sort of strategy for handling collisions. Just sort of calculate ahead. Calculate where I'm going to be rather than calculate where I am. And yeah, I'm also going to defer all of this. So I'm going to create a new array list of game objects. So array list of actually items. And yeah, game object called items equals a new array list of game objects, because this way I can sort of defer item picking up as well. And oh, right, almost forgot for some reason. That's alright. And it wants me to use diamond notation, but that's alright. So items dot add geo, and I'm going to move all this code down here, just temporarily. And I'm going to have to get rid of these spaces because it's going to bother me. So, yeah. Whatever, that works, that works. So that means I can get rid of these things. And now, if geo.getType, whoops, boolean move, by default equals true, so I'm going to assume I can move. So game object dot wall ID. Walls are going to be the things I can actually run into. Actually, you know what? I shouldn't do this with IDs, should I? Because that means the only thing I can collide with is walls. What if I want to collide with enemies, or what if I want to collide with something else? So actually, instead, I'm going to do it with a flag. So, yeah. And where is it? I know this method's here somewhere. It's not here? Huh. I could have sworn there was like a remove method I had in here. Or am I just missing it? No? It really does not appear that I have a move method. A remove method. Okay. So whatever, public boolean get, I'll call it solid. Whoops. That's going to return flags number 1. Oh, there it is. I was just, yeah. Public void. I'm going to call it set solid. That's going to set flags sub 1 equal to boolean value. There we go. That way, I have a way of telling if something's solid or not. And I don't need an extra ID tag. So, if geo dot get solid. So if any of these objects are solid, then I'm just going to set move equal to false. And I'm also going to break out for now. Actually, no, that could come out back and bite me if I change something in here. I was going to break out a loop to sort of speed it up, but yeah, that could really come back and bite me later, so I'm not going to bother doing that. And yeah, so now I just need a good way of setting that, but I'll worry about that in a bit. So now, if we're still moving, that's when we actually move. So x equals new x, y equals new y. So actually I should just do if not move, then return. Yeah, because that way, it's just a little bit nicer. This way, you know, there's nothing past this point that I want to execute after that. So, then, for, and actually I should just do for each. So for each game object, geo, and items, I'll go ahead and add every single item that I picked up to my inventory. And yeah, there we go. That appears to be just about everything. So first off, let's go ahead and test this to make sure it does everything as expected, just by default. Whoa. Oh dear. Oh, I see what I did. So right now, this actually it's kind of cool. Right now I have sort of an accelerator. Whoop. Because I forgot to reset the move amount after every iteration. So yeah, after every iteration, I need to reset the move amount. So I'll just go ahead and do that right here. Move amount x equals 0. Move amount y equals 0. Yeah. So there. So now I should be able to pick up that. You just picked up the cube. Excellent. Now I should be able to fight this guy. And I should be able to kill him, even though I had 1 HP for some reason. That's rather unfortunate, but hey. So good. Everything works out just fine. So now I'm going to go ahead and create my first item that has this elusive collision. Not sure why it's elusive, but hey. So I'm going to go ahead and create a wall. And because I'm lazy, I'm just going to copy the code from the cube. Whoops. Actually, I'm not going to have that though, so public wall. Oh yeah, of course, it extends game object. Almost forgot. Control-Shift-I. And I'm also going to have size as a floating point value, isn't it? Gonna check cube. There we go, yes. So, whoops. No, don't close wall. What? Close cube. Don't want cube anymore. So I'm gonna have a float size X and float size Y. So this way I can sort of just do rectangle approximations of the wall. So, also probably going to want to change the init method, because... But hey, I'll worry about that when I come to it. So name. Didn't think that had part of it. So yeah. It's still not right. What am I missing? Game object. Where have I... Ah, type. You know, I should probably just have public static final int default ID equals 0. So I'm just going to set wall to default ID. There. Excellent. I'm just going to make sure I have all these values exactly as I want, though. X, Y, R, G, B. I can have the same color as the cube. That's fine with me. And yeah, the only other thing I want to do here is set solid to true. That way, the game knows, hey, this thing's going to be solid. So now that we have things we can actually collide with, i.e. walls, I'm going to go ahead and add a wall. So objects.add new wall at location, the first parameters are the location, right? Right. Just want to make sure I'm doing this right. It's 200, 200. And it's going to have size x1 to really test it, and y 300. So there. Control-Shift-I. Come on, there we go. Now let's test it. So now I have a wall, and I can't run into it. Excellent. It's working. Problem is, enemies probably can. Can't they? Yeah, enemies just pass straight through it. But that's okay. I'll have to update their moving to detect solid objects, but that's fine. But yeah, the only sort of weird thing is, once you get close to a wall, sometimes it doesn't let you get right up on it, and I'm gonna kill this guy because he's bothering me. Yeah, like right there. It doesn't quite let you... Yeah. That's... I don't think that's that big of an issue right now, so I'm not going to worry about it. And yeah, so now we have walls. You know what that means? We can start actually taking this and sort of piecing together a level. So, first thing I'm going to do in this process is I'm just going to comment out all of this code right here, because I don't need any more. Right now, I just want my player. Right there. And it's from here that I'm going to start putting together the level. So, I'm actually going to create a new method. Going to be public. Void's going to be temporary method. It's not going to be permanent, but going to be called generate test level. And guess what this method is going to do? It's going to generate the test level. So, what I'm going to do is, first off, I'm going to try creating the walls. And later on, I'm going to create level editor so you can actually create levels a little bit easier, but for now, I just want to give you sort of the experience of, hey, this is what it's like to actually create a level. So, whoops. I'm going to create just a new wall based on that line of code right there. Essentially, I'm just copying that line of code over here. And we're going to see what happens. It's going to give me an error because I forgot a closing parenthesis. That's alright. If I try again, it doesn't work. Huh, oh, because I don't call the method, right. So after I do this, after I add the player to the level, I'm going to generate the test level. So that's my first wall, I'll say. Okay, cool. So now I want a second wall. So objects.add, new wall. It's going to be at position... Let's keep it at 200, 200 for now, and I'll sort of move it to position from there. It's going to be 301, so essentially the exact opposite. Actually, that works, huh? Okay, cool. So I guess I did my line drawing correctly. So yeah, this level is also going to go off the screen, so I'm going to have to start implementing side-scrolling at some point. But yeah, there you go. I have 2 walls. So now, if I go to position... I wonder, if I go up to 500, 200, does that automatically give me that for free? No, because that's the X position. Right. So now if I go to 500, 200, does that give me that for free? Aha! Awesome. So that just essentially completes the entire process of generating the walls for me. So there you go. I now have a box, and I'm trapped in a box. I gotta admit, it's somehow a little bit less exciting when you're trapped in a box, but hey, I'll take it. The only thing I don't want is this top wall right here. So, yeah. There you go. Now I can actually get out of the box and run around it. But I don't want to do that just yet. Just yet. I'm going to have one of these be 100. And I'm also going to move over 200, so 400, and have another one. And that should give me a hole in the top. Yeah, excellent. This is where I'm going to have my door. And I'm also going to have my hallway here, once I can actually get side-scrolling in. So, here we go. I'm going to comment this out and just say, generate first room. So there's that. I have the room, and I'm just going to run around it again, because it's kind of cool. This next part is I'm going to generate hallway 1. I'm just going to generate the hallway at this point. So, I'm going to copy this line of code, because object, no, not quite what I wanted. I'm going to copy this line of code. It's going to actually go at this point, and instead of moving that way, I'm going to move up 100. And I put it the wrong place. Oh well. Let's try actually 300. I think that's where I want it to be. Excellent. And it's at this point where side-scrolling is really starting to become an obvious necessity. So, what did I just do? No, I don't want it there. I want it to be at 400, 500. So, yeah. I now have a basic level. I can go up and stuff, but I can't really see where I'm going. That's a bit of a problem, so it's at this point that I'm really going to just stop, and I'm going to start implementing side-scrolling, because, well, I say side-scrolling, but it's not really anything like side-scrolling. I don't know why I'm saying that, but I'm going to implement scrolling. How about that? Not sure why I was saying that. So that the camera sort of actually moves with the player. And yeah, I'm going to go ahead and do that. Okay, so first thing you need to recognize about the whole scrolling thing, that's all just a rendering technique. It has nothing to do with actual mechanics. So this is all just an OpenGL thing. That's the only thing we're going to have to worry about here. So first off, all I'm going to do is I'm going to go into my game object. I'm going to copy the render method. Why? Because I'm about to go on my player class, and we're going to override it, because we want the player to render differently. We want the player to render so the whole screen scrolls with it. And yeah. So first off, the @ override, so NetBeans doesn't hate me. And second off, I need to copy this thing, the import for OpenGL. And yeah. Whoop, where is it? There we go. So, first off, let's look at the render code, because we haven't actually used any OpenGL code for a long time. What is this render code doing? What this is doing is, first off, it's saying, take the current point of reference, and go the distance of your position, so go off your position from it, and draw. So, it will take whatever point of reference it is, it won't change it because I'm pushing it onto the matrix, and I'm popping the matrix, and it's literally just doing that. Yeah. It's pretty straightforward. Take the old point of reference, save it, move to where you are, and draw. That's great, but we don't want the player to do that. We want the player to move the point of reference with it. So, first off, what I'm going to do is I'm going to get rid of all that. Whoops. There. No. Okay. it'd be nice if you did tabs, but that's alright. So right now it's saying, move the point of reference to where you are and draw. That's almost what we want, but what we want is we want the player to just draw, because we want the player to just draw in the center of the screen. We don't want any point of reference to do with it. Draw the player, and then move the point of reference based on where the player is. And since the whole level's drawn based on this point of reference, essentially the whole level is moving with it. However, we don't want to move to level 4, because if you think ink, when you're moving in a scrolling level, if you're moving forward, the level doesn't move forward with you. It moves backwards. It moves in the opposite direction. So we actually want to move in the opposite direction, -x, -y. And now this should get us something that kind of works. And as you can see, it does indeed do the side-scrolling effect. There's no issues there. However, the only real issue is, well, the player's drawn in the corner. The whole level's drawn based on the corner. I kind of want it drawn based on the center of the screen. I mean, if you like playing games based on the corner, I mean, hey, that's something you can do, but I want mine in the center. So what I'm going to do is I'm going to do GL translate F. I'm going to translate the whole thing to the center so I can draw the spray, because, you know, it's the same sort of effect. I'm not going to move based on the position. I'm wanting to move to the center of the screen. So actually I already have code that does that in my game. I have right here, display.getWidth, that calculates the center, so I'm going to do that. Exact same thing again. And Control-Shift-I, because I don't think it has it in there. And now if I run it, it should draw the player in the center, and everything should be moving relative to that. There you go, look at that. It's absolutely beautiful. Except maybe the slight offset and collision. But yeah, there you go. We now have side-scrolling in our game. Well, not side-scrolling. I don't know why I want to keep calling it side-scrolling. Our level now scrolls with the player, rather than just sort of being static. So yeah. And by the way, I'm pretty sure this only works if the player is rendered first. Because that's what's setting the whole reference point. I believe if I move the test level above the player, then it doesn't work. So, yeah. That's sort of the only something to this. If you really want this to... If you really want to make it work in every case, what you can do is you can set the whole render system to 0, so just make the render method nothing. The player doesn't have a render method, and just manually do this same sort of code, except at the start of the whole game rendering. And that'll make it work in every case, but the way I'm going to do it, I'm always going to load my player first when I'm loading a level or something, so that's never going to be an issue. So yeah, there you go. And yeah, another neat thing about this is our player's position no longer depends on the level. Not the level, it no longer depends on being in the center of the screen. So yeah, I'm going to keep it there just because it's what I already have. But yeah, you can now place your player wherever you want and draw your whole level however you want. The whole grid system is independent of any sort of screen space or anything. The game now has its own coordinate space. So yeah. And yeah, so now that all that's out of the way, we can sort of continue building our test level. So yeah, first off, I think I want the hallway to be a bit longer, so I'm going to do that, and I'm going to see how I like that. So yeah, now the hallway's a little bit longer. I think that's a good length, so I'm okay with that. So now, there's the hallway. Generate second room. We're just going to keep on going. So now, at this point, we'll do something a little bit interesting. So first off, I increased the Y positions by 200, so that should be 700. And now, this first one, I'm going to have at 200, and it's going to move 200 in X and 1. So the second one, I'm not really even sure what's going to happen. Yeah. Actually, I think it should be 100 next, shouldn't it? Yeah. So that should do that. That one's still just a line. That's okay. So the next one I'm going to have do, again, 1 in X and 100. I'm not sure if that's going to work or not, but hey, I'm going to see what happens. Didn't think so. Needs to be at 400. And now that should work. There we go. Excellent. So that gets those two. Now, at this point, I really just need to create the rest of the room. I mean, it's pretty straightforward at this point. It's not exactly the simplest system of generating rooms, but hey, it works. So, now these are going to be vertical, so that thickness is going to be 1. It's going to be up 300, I believe, because I believe this is the standard size of rooms I'm going for. And I want all of rooms to be about the same size. And you know what? That works. That works. So, yeah, that goes up. And now another one at 400 that does this. And I also want one at 200. Well, plus 300, so 1,000? And that should complete the room. If not, we'll see what happened. Okay. I didn't do something right. I think this one, the one at 400, needs to be sort of moved over by the amount. So perhaps at 500? There we go. So now we have 2 interconnected rooms. And this is sort of just what I'm going for at this point. So we have 2 interconnected rooms. We can go between them. We can run into walls. We can't exit. But yeah, there you go. Now all I'm going to do is I'm going to go over here. And I'm going to actually create the final room. Because if you remember from our sketch, yeah, we got this room, we got that room, we just need that room. So yeah. So that requires modifying the first room code. I'm actually just going to comment out until I find which wall is that wall. So, not that one. Yeah. I could probably do this a little bit more intelligently, but it's probably this one, isn't it? Yeah, there we go. So, rather than going up 300, I'm going to go up 100. So that way the wall is length 100. Perfect. Now I'm going to take this. I'm going to go up. Yeah, 200. Wait, what? No. 700. Wait. What? Hang on. No, that's X position. What am I doing? I'm going to go up 200, so to position 400. That should create this tiny little gap. Excellent. So now I'm going to generate hallway 2. So, whoops, probably should just copy and paste something. Where's that line I just added? This one? Right? Yeah. Take this, and rather than going up, I'm going to go sideways. And that, excellent. So this one should just need to do the same thing except down 1. Actually, I want these a little bit shorter, so I want these 100 instead of 200. A little bit shorter hallways. Yeah, why not? Awesome. So now I'm just going to take those 2 same walls. I'm going to copy them. I'm going to paste them. I'm going to move them over 100. So they should be at position 600 now. And that should get me that. Excellent. This is working out great, actually. So now I'm going to take the bottom wall. Actually, no, whatever. I'll just move from here. So this one's the upper one. I'm going to take the lower one, actually. So move down 100, so that should be at 100, right? And wait. Yeah, that's the lower one. So I'm going to move over 100 with thickness of 1. You could... Alright, move down too much. That's alright. Alright, because I forgot I'm drawing from the bottom, so that's actually already correct. And if you'd probably be better off doing this with, like, having constants for thickness of various things and such. I'm just doing it like this, because again, this is a test level. It's not going to matter in the end. And also I'm going to have a level editor, which is going to do this even better than I am, so yeah, there you go. So, this one at 400. Wait, no, 400 plus 100, right? So 500. And that almost completes this room. Almost. So now what? Just need a back wall, right? Right. So, is this a back wall? Wait, yeah, that's the lowest one, so I'm going to go from thickness 1 up 300. I'm just going to move this over 300, so it's at 900. And I'm going to see if this creates a back wall. Awesome. There we go. We now have 3 interconnected rooms, just like our diagram, except it's actually implemented. It's in Java, and we can explore it. And we also appear to be getting some lag. I don't know if that's from recording or if the game is actually lagging, so I'm just going to go ahead and test that. 1 second. Actually, I figure I might as well show you my frame testing code on camera, because you might be interested in testing your frame rate as well. So first off, I'm going to create a long time, which equals now. That's going to be system.nanotime. So whatever time in nanoseconds the system has at this particular moment. And that's going to happen every single frame. I'm also going to be counting frames every frame. So I'm going to have some int frames equals 0. And that's going to be counting up. Now here's the way this is going to work. I'm going to have some long called last time. That's going to be initialized to system.nanotime. And I'm also going to have an amount of time passed, which is going to be equal to now minus the last time. So essentially what I'm doing is just every single frame I'm calculating how much time passed between each frame. And then I'm going to also have some amount of total time, which is going to start out at 0. Total time, that's going to increase by the amount of time passed. And I'm also going to set the last time equal to the current time, because, hey, that's how it works, right? So this is literally just going to count the amount of time between every single frame. Now this is counting in nanoseconds. So when this total time is greater than or equal to 1 billion, because a billion nanoseconds in 1 second, so 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1 billion, then I'm going to reset total time, going to reset frames, and I'm also going to print out the total amount of time that happens. So just going to print out frames. And I'm going to see what happens when I'm recording, and I'm going to see what happens when I'm not recording. So as you can see, I'm getting a pretty terrible frame rate when I'm recording. 20, 21, 14. Oh dear. Well, that's alright. I'm going to see what happens when I'm not recording. See if it's my recorder or if it is indeed the game. Okay, I'm back. As you can see, I was having some pretty stable 60 FPS until I started recording. So it does appear that the problem is indeed the recorder. Alright, well that solves that mystery. I'm glad we don't have to do any optimization just yet. But yeah, that's just about all I want to cover in this video. We have a hallway, we have side-scrolling, we have new, better code for random number generation and stat generation. And we also have a way of testing our frame rate and performance, so I think we've accomplished a pretty fair bit in this video. So thank you, hope you enjoyed, I hope you learned, and in the next video, what we're going to do is hopefully continue building this level, and maybe we'll get doors working, maybe we'll get keys working, maybe we'll put a few monsters in there, who knows. We'll keep building the test level, and yeah, so hope you enjoyed, and I'll see you next time.